Okay guys, what we're going to do today is we are going to go ahead and we are going to do 1-5 notes over solving inequalities. And I'm trying something new today, as you can tell. We're going to try to see if helping you see me is going to help you learn the notes a little bit better. So who knows? Okay, first things first, what is an inequality? An inequality is a statement where the right-hand side and the left-hand side are not equal. So the inequalities that you're going to be looking at are not equal to, greater than, less than or equal to, or greater than or equal to. Now, how many of you usually struggle with learning the alligators and the crocodiles and stuff like that, and you use that? What I want you guys to do is I literally want you to put 0 on a number line. And all of the numbers to the right of 0 are greater than, so therefore when the arrow points toward the right, that's the greater than symbol. When the arrow points to the left, that is going to be the less than symbol because it is smaller than 0 over there. Okay, so that's one thing you need to know. The next thing you need to know is the closed dot. A closed dot means that that can be a solution, that it is a solution to the value. You are including it in the answer. The symbols that are going to be a closed dot are greater than or equal to, less than or equal to, and equal to. Those three symbols require the closed dot. Okay? Now, an open dot is the number is not a solution to it. So basically what you're doing there is you are excluding the values and you are saying, okay, it is strictly greater than or strictly less than or strictly not equal to. Okay? So those are the things that we need to talk about. And here are some other symbols that we will have. Okay, we have the infinity symbol and the negative infinity. Infinity symbol is the largest number in the world. And then negative infinity is going to be the smallest number in the world. Super important that you get that. Now, we have 4 other symbols. We already talked about this one right here. This excludes and this excludes. They are exactly the same concept, okay? Now, what includes is going to be the closed dot and the brackets. Brackets mean that it can be that value, so you want to keep it, okay? You never, ever, ever use a bracket on an infinity symbol. You always use the parentheses. So, we have 2 types of notation. We have set notation and we have interval notation. So the very first one that we're going to learn is going to be set notation. Set notation says X is a member or a member of the family of the real numbers. So every number in the world that you can think of, that is going to be a real number. The comma says such that X is less than or equal to 14. So if I have 14, less than or equal means it's going to be a closed dot. And then my shading is going to be the direction the arrow is pointing when X is on the left. So I simply shade down, okay? Interval notation looks like an ordered pair, but it's totally not. It is just simply going to be a starting point and an ending point. So the starting point for me to shade is going to be all the way down at negative infinity, and then this thing is going to go all the way to 14, except for I have a bracket at 14, and the bracket says that it can be 14. So that is another example of that, okay? Biggest and most important thing you must learn. If you learn nothing else, learn this, okay? When you multiply or divide by a negative number, you must flip the inequality sign. You have to. The reason why we do this is so we can make the statement true. If you do the math right and you don't flip the inequality symbol, then what's going to happen is you're going to have a false statement. And you can't have a false statement. You need to have a true statement. Okay? So, example. Here we go. Negative 2x plus 4 is less than 8. We are going to pretend that the inequality symbol is an equal sign. That means I would get rid of the 4 first. How would I do that? By subtracting 4 from both sides. So from left to right, I drop down the negative 2x. I cancel out the 4's, drop down the less than symbol, and I have 4. Now I need to go ahead and I need to solve for x. So the negative 2 is attached by multiplication, so I'm going to divide both sides by a negative. So now that means that the negative 2's cancel out, but what do we have to look at? Is our sign. We ask ourselves, did we divide by a negative number? And the answer to that is yes, I did. I divided by a negative number. So the less than symbol now turns into a greater than symbol, and I have x is greater than negative 2. How do I graph that? Put -2 on the number line. Okay? Then we're going to go ahead and have a closed dot, or an open dot. That's an open dot at -2, and the arrow is pointing toward the right, so I shade to the right. And you are done. Okay? Let's do another one. Same exact concept. I have like terms over here, so since I have like terms over here, I need to go ahead and combine those like terms before I do anything else. Drop down the -1 and the less than or equal to, and 4 minus 5 is going to be -1. So how do I solve this? Add 1 to both sides, and I get 0 is less than or equal to 2n. Now, I need to solve for n. So what's attached to the 2n? The 2. So I'm going to divide both sides by 2. 0 divided by any number in the world is just going to be itself, which is 0. Now, y'all don't like the way that's written because we're used to seeing the variable written on the left-hand side. So what do we have to do? We are going to pick it up and turn it around. So if we do that, I want you to look right here and say, okay, well, where is that arrow pointing? That arrow is pointing toward the 0. So when I flip it, this arrow needs to still point toward the 0. So I'm going to have greater than or equal to is 0, and this is the one that we all like, because whenever I graph this now, I can put 0 there, and I can have a closed dot, and I can then shade the direction the arrow is at, which is going to be larger than 0, which is to the right. Okay? Next, 2p minus 4p is less than or equal to -2. I'm going to go ahead and combine like terms. 2p minus 4p is -2p, less than or equal to -2. Have to get rid of the -2 that's attached to the p, so I'm going to do that by division. So p, guess what? I divided by a -2, so I'm going to flip the inequality sign, making that p is greater than or equal to 1. I throw 1 on a number line, and I ask myself, is it supposed to be solid or dotted? It's going to be solid, or if I wanted to use a bracket, I could do that as well. And then I'm going to shade to the right. Okay? Next one, same exact concept. Pretend it's an equal sign. Drop down the left-hand side. Distribute the -4. So this is going to be 24 minus 12a. Then I take the smallest a. The smallest a is going to be this a right here. So I'm going to add 12a to both sides. So this is going to give me a 13a minus 15 is greater than 24. Yes? Now I need to go ahead and add 15 to both sides. So working from left to right, the 15s cancel out, and this gives me a 39. So again, I'm solving for a. I divide by the 13. I did not divide by a negative. See, right here. I divided by a positive 13, which means I'm going to go ahead and keep the sign, and that's going to be a is greater than 3. So how do I graph that? Throw 3 on the number line. Is the line underneath the symbol? The line is not underneath the symbol, so I have an open dot at 3, and I shade the direction the arrow is pointing, which is to the right. Okay? Same concept. 26 plus m greater than or equal to -30 plus 15m. I take the smaller m. The smaller m is going to be this 1m. So I'm going to subtract from both sides. It's greater than or equal to -30 plus 14m. Get rid of the 30. And I have 56 is greater than or equal to 14m. Divide by 14. And 14 times 4 is going to give you 56. And do we like the way that's written? No, we don't, because the m is on the right. So we're going to pick it up and flip it around. So if we're picking it up and flipping it around, the m is where the arrow is pointing toward. So that's where the arrow needs to point whenever we are flipping it. So that, therefore, I have, here's 4, and it can be it, so I have a closed dot, and I shade down to the left. Okay? Same concept, 6x plus 3 is less than or equal to 6x plus 12. So I'm going to subtract 6x from both sides, and I have 3 is less than or equal to a 12. When is 3 less than or equal to 12? Is it sometimes true, always true, or never true? Well, 3 is always less than 12, so since that is always true, does it matter what x is? It does not, so therefore it's all real numbers. Okay? This one you might get on your homework, so pay attention to this one. Add the 5. -7 is greater than r over 8. How do I get rid of that r? Or I should say, how do I get rid of that 8? You are going to multiply both sides by 8. So I have -56. I do not flip the sign because I multiplied by a positive 8. I don't like the way that's written, so I pick it up. The arrow is pointing toward the r, so the arrow needs to point toward the r here. And then that is done. So I have -56. Can it be -56? No, it cannot. I have an open dot, and I shade down. Same concept. Subtract the 2a. -4 is greater than 3. When is -4 greater than 3? Is it sometimes true, always true, or never true? -4 is never greater than that. This is a false statement, so therefore no solution. Okay, now I want you guys to actually read the words, come up with a statement, and then solve it. So how do I go about that? -3 times a number. So -3 times means multiplication. A number, I don't know what it is, so it's going to be x, is at least 9. What does the keywords at least mean? Does that mean it can be bigger, or can it be smaller? Well, I like to think of it as driver's license because that's where you guys all do really well. You have to be at least 16 to get your driver's license. Can you be older? Yes. Can you be younger? No. So if I'm at least 9, I can't be 8, but I can be 10, so that means I'm greater than or equal to 9. How do I solve this? Divide by -3, and I have x, flipping the sign, is less than or equal to -3. How do I graph it? Here's -3, close dot, and shade down. Last example. A number decreased. Decreased is your key word there. What does decrease mean? Does it mean add, subtract, multiply, or divide? If I'm decreasing, I'm going from here down. So I'm taking away. So I'm going to have a number x, and I'm going to subtract off of it 6. And it is greater than, did it say greater than or equal to? It just said greater than. So I'm going to have the greater than symbol, -5. How do I solve that? Add 6. X is greater than 1. Here's 1. I open dot and shade to the right. That is it, guys.